People, hope we're doing okay. This is the fifth and final video for trigonometric integration. It's been a lot, I know, but there are just, first of all, it's never a bad idea in calculus to go over things that help us review our trigonometric IDs. The second thing is that you basically approach a section like trigonometric integration and you would think that it would be one thing, but it's a multiplicity of strategies based upon different forms of an integrand that have trigonometric functions and require a change in form using a variety of trigonometric IDs. In this video, we're going to be dealing with ones of this form, okay? When you have a product, now in the past we've had stuff like, sine x, sine squared x and cosine cubed x dx, where the power between the two factors was different, but the angle measurement was the same. In this case, we actually have the angle measurement being different and the power being the same. And basically, we're going to go ahead. I'm going to include at the top of each page the required product to sum ID that we're going to use, and it actually winds up being really, really straightforward. We can plop the half out in front. We're going to need cosine of, u minus v. And of course, I can turn this around if I want in order to avoid the negative. But then again, cosine is even, so it really doesn't matter. So even if you put cosine of negative 2x, cosine of negative 2x is cosine of 2x, because like I said, cosine is even. And basically what we have is that. Okay, well, from here we can, of course, integrate really, really easily. And basically, cosine of 2x is the derivative of 1/2 sine 2x. And cosine of 4x is the derivative of 1/4 sine of 4x. So we integrate them like this. And we wind up with 1/4 sine 2x plus 1/8 sine 4x plus c. But remember, like I said, you don't actually need this up here because the product to sum, basically all of the identities that you learned after the sum and difference identities all basically flow logically from them, okay? And so you should be able to do this in another way, and you actually can. I'm just going to show you how wonderfully inefficient it is, okay? So what you get is, if you need to actually get this down so that it is in terms of trigonometric functions that have the same angle measurement, then you basically need to take x, or 3x, and turn it into a sum formula. Well, if that's the case, then remember that cosine of a plus b winds up being cosine a cosine b minus sine a sine b. And then, of course, we still have double angles in there, so we still have to resolve those. And so what we're going to do is let's clean it up for one step before we actually attempt to do that. So we get cosine squared x cosine 2x minus sine x cosine x sine of 2x dx. Now, this second one, actually, because it's got sine x and cosine x, you can actually use a bit of clever IDs to turn that into something else. So let's go ahead and just rewrite this first one. Let's split it into two integrals. I think that's going to be helpful. And if I have sine of 2x and then sine x cosine x dx, if I put a 2 in here and a 1/2 out in front, I can use this. This right here becomes a second sine of 2x. Okay. Okay. Now, what I'm going to do is, if that's going to be a second sine of 2x, I need to turn this into cosine of 2x, which of course means I'm going to use my power reducing. And so let's do that in both of these. Cosine squared becomes 1 plus cosine 2x over cosine 2x dx minus 1/2 sine squared 2x And, oh, sorry, that's just talking too fast and not thinking. Sorry, guys. So basically, this could kind of become a 1/2 out in front as well. And so we can kind of split this up a little bit. And actually, with a little creative work, I can pull the 1/2 out here, have the basically have the cosine 2x, times cosine 2x. Gosh, I'm totally fumbling. And if I distribute this, this can become cosine of 2x dx plus 1/2, and then I'm going to take the cosine squared 2x, and I'm going to combine it with the sine squared, because if they go together, they create another double angle identity. Yes, I know, this is nauseating, isn't it? I get it. So that becomes cosine of 4x, right? And so what I have here is I have 1/2 the integral of cosine 2x plus cosine of 4x dx. And if you'll notice, this right here is that first step right there. It took me all of this garbage to do the work that the product to sum. So now, I mean, you got to remember that that's all that formulas really are. Formulas are just ways of taking something that you can do the long way and turning it into a memorable little thing. The problem is the fact that this really isn't all that memorable. And you use it so seldom that you don't memorize it by using it. And so when the time comes, if I ask you to do something like this, I, of course, will provide those for you, okay? Let's go ahead and move to the next one. I don't need you necessarily to memorize them, although if you want to, get down with your bad self. But I do need you to have facility in using them, okay? So in this one, really, again, plot the 1/2 out in front. Now I need sine u plus v, so I'm going to add those two. So it's sine of 3x. And then sine of u minus v, it's x minus 2x. And this time it does matter because sine is odd. And so that becomes sine of negative x dx. So what we get here is 1/2 sine of 3x minus sine of x dx. And of course, we can very quickly move to the actual integration of those. Sine of 3x, it is the derivative of negative 1/3 cosine 3x, or it integrates into that, right? Which means, of course, the same thing. And of course, negative sine becomes positive cosine. And then, of course, the obligatory plus c. Let's go ahead and distribute that 1/2. And I'm going to forbear on actually changing the form of this. You could actually, this one really isn't all that bad. You could just change that into 2 cosine squared minus 1. And then, but you're going to get something that is really different looking than this, and in order to confirm that the two are equivalent, would then take all of those nasty steps that I showed you in the last problem. Let's go ahead and let's do another one. And obviously this one, you should be able to see that you can change the form right here, because this is going to be a double angle and can become 2 sine 2x cosine 2x if you want. And that actually doesn't wind up being all that bad. It just gives you, again, a different... basically, the answer is equivalent, but it looks very, very different. So let's actually do it both ways, but I'm not going to do the hard work of showing you that they're equivalent, because just no. So let's do the 1/2. And we have u minus v, so 2x minus 4x. But cosine, again, is even, so it winds up being cosine 2x anyway. And this is cosine 6x dx. And when I integrate, that becomes 1/2. This one becomes 1/2 sine 2x. This one becomes 1/6 sine 6x. So we have 1/2 sine 2x minus 1/6 sine 6x plus c, or 1/4 sine 2x minus 1/12 sine 6x plus c. Like I said, if you use the double angle identity and you get sine of 2x, and then basically you're treating 4x as if it's 2 times 2x, you get cosine of 2x dx, which gives you, you bring the 2 out in front, and you get the sine 2x squared, and the cosine 2x dx becomes almost my du. I just shouldn't have put the 2 out in front. I should have put it with there, and now I have u squared du. This becomes 1/3 sine cubed 2x plus c. And if you're sitting there thinking to yourself, those two are equivalent, yes, those two are equivalent. But you don't want me to do that right now, I promise. Okay. Actually, if you do want me to do it, I can show you later. I'll show you, whenever you want. But I'm not going to do it right here, just for the purpose of getting to this last one and not making this video any longer than it has to be. Our last problem, ta-da! This is another one that's just cosine times cosine, so we're going to go ahead and plot the 1/2 out in front. At that point, what we're going to get is we're going to get cosine of 3x minus 5x, or negative 2x, but again, cosine's even, and then plus cosine of 8x dx. Now, upon finishing that, what we need to do, of course, is just do the integration like we've been doing it the whole time, and this becomes 1/2 sine 2x, and this becomes 1/8 sine 8x plus c, and of course we just need to distribute the 1/2 just to do some rudimentary simplification in order to get this in its final form, and ta-da. Okay. I hope these videos have been helpful. Along with the homework that I'm going to post that will have an answer key, I hope that winds up being helpful, very, very helpful. Be on the lookout for that. Again, if you have any questions, please do shoot me an email. Bye.